everyone. Good morning, good afternoon. You're very welcome to our second virtual EMEA meetup in the past few weeks. We are joined by Milan from ACTUM Digital. And Milan will be presenting on their Search Odyssey of powering auction discovery with Elasticsearch. This presentation, if I'm correct, was given last month in Prague. And we didn't get the opportunity to record it, so we thought we would bring it to you all on the virtual stage. My name is Nisha. I work on our DevRel team here in Elastic, and we're delighted to have you all joining us here virtually, and for those of you that are joining us afterwards on the recording as well. Following this event, we will have some links and some kind of direction on how you can get involved in speaking at a meetup virtually or in person like Milan, or both like Milan as well. And if you have any questions or anything throughout the presentation for Milan, you can just pop those into the box. We have Piotr here as well to help us with that. For now, I'd like to pass you over to Piotr. I'm also going to, while Piotr's speaking, I'm going to pop up a little QR code on the screen where you can enter our competition. I'm sure some of you are excited to try and win some swag. So I'll pop a link up to that on the screen and the QR code while Piotr is speaking. And I'll pass you over to Piotr now.
Hello. I'm Piotr. Just as Nisha, I work for Elastic as developer advocate. Basically all things Elastic. Yes, I've met Milan last month when he was giving his very nice talk about their journey or their experience with Elastic. Should you have any questions in the meantime, please ask them. Should you have any questions later, don't hesitate to go to Discuss Elastic CEO. And Milan, why don't you introduce yourself?
Hello, everyone. Thank you, Nisha. Thank you, Piotr, for nice introduction. My name is Milan Gatyás. And I'm here to present our Search Odyssey, powering auction discovery with Elasticsearch. Shall I start?
Yeah, you can go ahead and start. The screen's up for you.
Okay, thank you very much for information. Few words for introduction. The company, ACTUM Digital, we empower our clients with digital platforms. We are consultancy and technology providers for our clients with wide range of technologies, one of them being Elasticsearch as well. As I said...
Sorry, Milan, I'm just going to jump in. It's still not full screen. If you want to just pop to the bottom and put it into presentation mode for yourself there, then it should be full screen. Just I think you removed your screen there. If you want to just share again.
Sure. Sorry for...
No, you're okay. These things happen on the virtual stage.
Yes, unfortunately, sometimes.
Perfect. That's it up.
Is it better?
Yes, that's perfect now. I'll pop off and let you give the rest of the presentation. Thanks.
Thanks a lot. Yeah, my position is a cloud architect, and I'm passionate about improving the search experiences. And that's why I decided also to apply for a Meetup to share our stories, share our success story of using Elasticsearch to power auction search. And that's what I'm gonna guide us through today. I would like to start with saying that an implement of the finding the right auction lots is a challenge. It was a little bit more challenging than I expected. And the reason was that multiple factors were combined when it came to, for example, high search performance requirements. It has to be fast, but at the same time, we needed to synchronize data in almost real time. And on top of that, we needed, for example, sometimes very complex sorting criteria to fulfill the relevancy order expectations of our stakeholders. And also on top of that, we had several specialties like some maybe artists' names. They can have multiple representations of their names and so on. And Elastic was of great help, and I will touch on some of these points in this presentation as well. The Search Odyssey started for us in 2020 when we initiated the replacement of the previously used search engine, and we went with Elastic 7.1 hosted as a managed service in AWS. The previous search engine was Autonomy. I'm not sure if you ever heard of Autonomy. For me, it was the first time. It is, I believe, originally search engine based or developed by British company, which name I cannot recall right now, then bought by HP. And we did not choose to continue with this engine because I think one of the main reasons was lack of know-how on our side. Also, this engine itself, it was on-premise, and we did not really wanted to invest time into upgrading or, let's say, maintaining the infrastructure for the search engine. From the client, we also heard that it has really not great monitoring, and it is hard to customize. So the factors combined together made us rethink and choose other provider. At the same time, when we just looked up the popularity of the engine itself, we saw that it had its peak. It's no longer very maintained or active and popular among the community. When I just compare this with Elasticsearch, for example, it's visible that it's a very different story. And also, just out of interest, I did the comparison on the Google Trends across current major search provider, and Elasticsearch is still very on top. This was, however, not the main reason why we chose to go with Elasticsearch. We did it because we had some requirements, and Elasticsearch ticked every box of those. The main, or let's say one of the main requirements was that we want the search engine to be easy to configure and use. As I mentioned, we did not really want it to maintain upgrades, blue-green deployments of new versions if there are some breaking changes and so on, or even patching the servers. And this was possible. On AWS, Elasticsearch was provided as a managed platform, so we could just configure our clusters, nodes, say the specifications, how strong the machine should be, and all was done. We were ready to go and start using the engine. That was perfect for us. At the same time, we really wanted to have a great documentation because that is, I would say, one of the biggest factors for your success. You need to be able to read about every feature, have a lot of examples, and understand how things works and how to combine with another features. And for this, I would say Elasticsearch, or in general Elastic documentation, is superb. I would say one of the best I was reading, so really wanted to stress this point here. It is really pleasure to work with Elastic documentation, and it helped us to get the speed and develop in a rapid time. I would say in a record time even. At the same time, we wanted to have the powerful querying, filtering, and sorting, which Elastic for sure has. It has all the features we needed to migrate and to extend our search solution for auction search. And at the same time, it allowed us to customize the things that we found not to be ideal. And I will also a little bit describe this later. We also needed cluster replication because of the disaster recovery. Our solution had to be highly available and ideally across geographical regions in case there is some outages, as we, for example, so just a few days ago with Azure. And features are working out of the box. This was really great. And we had some experiences from before, so we know it is like this. Most of the time, you read about feature, you take the snippet from the documentation, maybe fine-tune for your needs, and things works. This is really great. It's visible that the product itself is designed in a way that you can just grab the features and use them, and they most of the time works out of the box. This was really great. And we used many features of Elasticsearch, and unfortunately I cannot disclose very much details about the especially infrastructure around Elastic because of NDA and so on. I can say that we used many services to get data into the search engine, and then another set of cloud services to get data out of the engine as a queries and so on. What I would like to mention though is one feature of Elastic that helped us, especially when it comes for index and data management, and that is aliases. Because what you most likely want when you are, for example, creating new index, because you maybe changed some analyses or you added some field and so on, you would like to do it in a way, often in a way that you can do it as a blue-green deployment, meaning you prepare your new index in the background, you continue using current index, and then when the time is right, you can just switch to this new. And also, if you notice something is wrong, you can very fastly go back to previous index. And this is what aliases allows you to do, because you can point alias to index that you are using currently. You can build your new index in the background without any traffic going to it in terms of reading. And when you are ready, you can say remove the alias from the current index and point it to the new index. And also what is very, for example, if you, in the meantime, you also get updates, which you would like to reflect on both indexes because you don't want to lose any real-time data, you can use two sets of aliases. One is for reading, and this one will point only at one index at the time. So you can switch to the new index when you are ready, and you will have write alias, and this alias you can use to propagate the real-time changes to both indexes. So this blue-green nature of deployment of new indexes was really life-saving for us. It paid off many times, and it's a tip I wanted to share. Maybe you're already using or you're considering to use. In terms of the feature for the search itself, we use really, let's say, out-of-the-box features, which are proved to be very useful and working very well. So for the search itself, we use the matches, multi-matches, and phrase matches all together, sometimes just some of them. But in general, this provides us very great support for the full text or keyword search itself. We use also, for example, scoring function that allows us to amend the scoring of the results, so to adjust the relevancy based on our custom needs. We use nested Boolean queries, term and range queries for filtering. So, for example, if you want to filter lots by whether auction already happened or is it already passed, or you want to maybe filter by artist or let's say category or medium of the art, you can do this easily by filtering. Or you can use range queries when you want to, for example, filter your results by prices of estimate for the auctions or based on the price of the realized after the item is bought. We used faceting, or let's say to ensure faceting, we used term aggregations. So this was used to be able to render the checkboxes themselves. And for the pagination, we used built-in feature of from plus size query parameters when doing the search. So all this, basically the whole search function, we built from the built-in features. And we did not really had to customize that much. We also used stemming, for example, and synonyms to a little bit tune the relevancy and recall of our search queries. And we use term suggester, for example, to give us the did you mean functionality. So if you, for example, search for Pablo Picasso, but you miss one S, you get the nice label saying, did you mean Pablo Picasso with two S's? And I would like to stress the results because they were really impressive. We were able to utilize these built-in features in a record time. At the same time, we were able to do 10 times faster queries than previous search engine, and while keeping total cost of ownership reduced by 90%. So clearly, maybe the previous solution was not optimal, but I would say combination of the having faster queries and reduced total cost of ownership, this is a strong indicator that the product itself is really good and definitely look to be better than the alternative. And we also greatly improved the search relevancy. I will touch upon this a little bit more later in the presentation. So as I said, all was good. All the features worked out of the box, but we did also a lot of fine tuning. There were moments where we scratched our heads. We were not sure why certain things work as they do. And I will try to, I picked few of those and I will comment on those, and I hope it will come to you handy or maybe in the future. For example, when we were fine-tuning the relevancy, the original version of search was doing the keyword search on, let's call it on strings. What does it mean? It did the keyword search with the same setting across the different fields, let's say titles and some metadata fields. And it was providing results which were not optimal in terms of relevancy. I will give an example. For example, if user searches for Pablo Picasso, there is a lot of results. One of them can be this painting from Andormi, which was sold for almost 43 millions. It is a very relevant result for the query. This is what stakeholders would wanted to see when users search for Pablo Picasso. But at the same time, you can get the result of Atelier of Pablo Picasso, which is also related to Pablo Picasso, but maybe not exactly what users were trying to find when they searched for Pablo Picasso. And we might argue what is the more relevant, but we could say that if user would like to see Atelier of Pablo Picasso, they would write into search bar Atelier of Pablo Picasso. So how we can make the search more intelligent and promote the actual things, actual paintings of the author? We did it by boosting the structured data fields compared to the free text fields, such as title of the lot. So we did a search and we said, okay, for the titles, there is a default boost, but when it comes to field for name of the artist, for example, we boosted it higher. And this we did basically for all metadata fields. So hit on the, or match on the metadata was giving relevancy much higher than the hit on the free text fields such as titles, because you can get really unexpected data there and it can mix the relevancy. So for us, this was the winning formula. And I would like to stress that if going this route, it's very important to have good quality of classification and categorization of your data, because in that case, your search can be only as good as is your classification. And for example, having missing values or duplicates or not really consistent metadata, it can make your search result really worse, even if not using any boosting on metadata. So it's like complementary work that needs to be done. Your metadata needs to be of very high quality. Another example, what we faced is, for example, there is this painting. It is Salvator Mundi. It was sold for 450 million in New York auction in 2017. I think it is the most expensive painting auctioned. And if user searches for Leonardo da Vinci, who is author of this painting, then you might want these results to be, let's say, somewhere on the top. You don't want to have it on second page or third page of your search query. And this is something similar was happening. And the reason might be you are ordering your search results by score, and based on the BM25, this of course takes into consideration how long is the field where you had the match, and what is the uniqueness of the keywords that being matched. And it might happen that some other items that are also valid search results might be more relevant. They might have higher score just because of this algorithm, but it's not what you actually want, because maybe you want to promote the more prominent items, more exclusive items, more expensive items, or items that were sold more recently than some older items. And for this, what it means is that BM25 was not the only factor to consider when doing the relevancy. And what we used is a scoring function, and we could incorporate the fields of the document and in a mathematical way adjust the scoring, the final score that was assigned to the result. And by that, we could basically move the item across the results higher or lower. For example, this is the snippet of the code that demonstrates using the scoring function. We can see two functions. One is affecting the score based on a field named realized price dollar. It is having modifier of logarithmic curve. And second function is based on sale end date. It's the Gauss curve. There is a scale of 10 years, so 5 years into future, 5 years in the past from the origin with some decay. And these two functions, there is a score mode of sum. They affect the result. They affect the scoring value of the item. They sum together and affect the result score. So this is, for example, the way how you can play around, how you can fine-tune your search results if you have special needs for order based on attributes of your data. And you can have much more functions, much more exotic, different score modes. You can, for example, pick only the most participating function, and the rest of the functions will not participate to the final score. So there is really a lot of options you can achieve or use by scoring functions. Stemming was also, it gave us one surprise I would like to mention. It's a really nice feature. Stemming gets the root of the word Mostly it is used for singular versus plural. So when you are searching, for example, for diamond, it can match the diamonds as well, because the root of the diamond or diamonds might be diamond. And this is how stemming can somehow normalize your data in a way that you don't need to think about these edge cases when your data is singular or plural. And also it can handle some more exotic cases if you don't use algorithmic stemmers. So it is very useful, but there are some cases when you need to be aware that it might have side effect. For example, there is a word Hermes, which is can mean more things, but let's say user intention is searching for the handbag of this brand. And when you use stemming on this, it actually produces token Herm. And Herm is a pillar into which the face is carved, usually of Hermes, but it can be also someone else. And this is already something that is not Hermes handbag, but you still can get a match if you have such documents. And even worse, you can have a fuzzy in your match. You can say you allow one misspelling, and in that case, you can match, for example, some book from Ernest Hemingway, which contains hair in the title. And this is very, very unrelated to what you are searching originally for. So these are edge cases. You need to be aware and inspect your, for example, what we are doing. We take a look on the most popular queries, we run them, we observe, we take a look on the relevancy. If we see some off results, or let's say some edge case abnormalities, we inspect and correct. And for this particular case, you can use built-in feature again. So Elastic thought about this issue. You can use the keyword marker token filter, and you can say, for example, Hermes is a keyword. It's a special keyword. Don't touch it and don't stem it, because it will cause issues. And in this case, you will not have the problem I mentioned above. Another thing, but this one is more about performance than relevancy. We faced some very interesting problem, and it took us some time to find out what is happening actually. Take a look on this query. So it's simple. It is just saying that your results must, on some field, the value must be greater or equal than 6 million. And we can see there is 379,000 results, and it took 18 milliseconds to calculate and return the first page. We can write the same query to have the same results in the same order, just by negating the bool. So in that case, the query might look like bool must not, but this time the range is on that field is less than 6 million. It's the same results, but you can take a look on the took of the second query, and you can see it's 290 milliseconds. So it's more than 10 times worse. And we were not able to, out of the box, understand what is happening. But fortunately, it is not issue we faced the first one. I found this post on the Elastic forums, and this post basically says, Adrian is explaining that when you are doing must, the filters, the items are first filtered. And then if you have some must not, for each of the result, the must not check is performed. And the thing is, in that our second query, if there is no must, implicit must is created, and this must is saying match all. It means every document is a result in the must. and the check for the must not is performed on every document. So in our case, it was this 300,070 items, and that was the reason why the performance was so bad. And for example, Adrian also recommends that for the Boolean fields, you can, when indexing, you can index both true and false variant of that field, so that you can always use the Boolean query that fits your needs. So it's not like you cannot use must not ever. You can use, they have its place in your arsenal, let's say, but there are these edge cases you really need to be aware of if you want to maximize your performance. Also related to performance is aggregations, which we used for faceting. I will put an example where you would like to get back more than one value, because how aggregation works, for example, term aggregation concretely here, when you are having the document that is having material, and this is like a document, or let's say object typed value, so it has some inner fields inside, ID, to, value paper, and so on. And you want to, for example, do your faceting for material, so you can see how much items are of material paper, and so on. You can just do this simple aggregation. You say that term aggregation on the material field, and you want 10 of them, for example. And you get back what you expect, like 2 documents of material paper, 1 of glass, and so on and so on. But the problem is maybe you want to get back more than just material value, because maybe you want to get the ID. So the problem is you would like to get from aggregation more information than just field on which you're aggregating. One option is to use inner aggregation. So for example, you can use the top hits for each bucket. So for each material, you will get one document, so that you can basically take a look into it and you can look up what is the ID. So you can see for bucket of key paper, you have the inner aggregation, and it says that value paper has ID 2. But the issue for us was that this inner aggregation only made twice worse performance. So we were thinking how, or if even possible, to improve this. And what we found out is almost like a workaround, but it works well, and we did not really face edge case so far, is that basically we can serialize the value of the material and ID into one field. We can call it, I don't know, ID value, and then we can make aggregation on that. And you get back buckets where you have both information. You have your ID and you have your name of your material. And you only thing you need to do, you need to parse the response. And the performance-wise, this aggregation has the same performance as the first query. So this is how we solve that problem of getting back more information than what we actually needed, or let's say specified in the original query. And last point I would like to mention, because this was also a little bit head-scratching scenario for us, it's about the scripting, because Elastic is very concrete, let's say. It says scripting should be avoided if you would like to have a speed performance, good performance for search. But there are scenarios where it's not so easy. For example, this query. This query is somehow, you can see it in the source. Somehow it is related to params now. And this now param, it means current date. So we are trying to sort. We are trying to return some sorting value of the document. And this depends on field value in comparison to current date. What it means that it is not something you can easily pre-calculate before indexing document into Elasticsearch and then use it as a simple field to sort on, because the value might be 1, because it's in future, but one day later it can be 0. So it's not so easy to just, or even possible to calculate once and use it forever. And at the same time, scripting like this makes your result slower, and more slower the more query results you have. So it might be okay for the small query result sets, like hundreds, but as you go to, let's say, thousands, you will definitely notice the impact of the script. We have this problem. We have date-sensitive information. We cannot pre-calculate once. So what we did, it's one of the solutions. I already heard another possible solution, but what we went with, and it works very well for us, we moved this problem a little bit outside of Elastic itself. We are scheduling the recalculation of the field value externally. So if I will share just a very simple snippet or sketch, what it means, when we are inserting the document into the Elasticsearch, we can say availability. Let's say this is the case. We care about lot availability. If it's still upcoming, is it in an upcoming auction that will happen or is happening? In that case, the result should be first. Or is it something that is past in the ending auction, that auction already take place like yesterday or 1 year ago? In that case, the result should be after all upcoming auctions. And so let's say this one is upcoming. We index in a way, say availability 0. The query itself will just use no script. It will just say, sort me by the field availability ascending. So 0 will be before 1. And at the same time, some, let's say, worker, it can schedule the recalculation process. So if you are not getting this automatically from somewhere in your application, you can do it yourself by some scheduling mechanism. And this process will trigger at the right time, and it will just update the document, like update by query or update, and it will set availability to 1. So the item, the document will become at the right time past availability 1, and it will reflect your sorting. So this was the solution we applied for sorting on date-sensitive data. And we did all this. We have a great results. Are we done yet? Not really, not yet. We are actually planning much more because right now we are on Elasticsearch 7.10 in AWS. We would like to migrate to the newest version of Elasticsearch in Elastic Cloud, because there is much more exciting new features. For example, hybrid search, to combine full text search with the vector search. This is something that very interests us, because full text search is great. You can add all these synonyms, you can play around with fine-tuning the scoring and so on, but some cases are really that hard. The full text search is no longer good. And we expect that the hybrid search will help us in this area to get a little bit of more meaning into the searches by using vectors and searching in the vector space. And learning to rank and much more. There are much more features we would like to explore. Just to summarize, we used Elasticsearch to our journey. It was a great choice. That's why I decided to share this experience and the insights we had. We got 10 times faster search results. We reduced at the same time costs, which made our stakeholders very happy, and we were able to enhance user experience on the way as well. Thanks for your attention. If you'd like to follow me, you can on Medium, for example, where I post articles, also on Elasticsearch topic. And I invite you to explore the power of Elasticsearch yourself.
Amazing. Thank you so much, Milan. I think your ability to tell like a real story and a real arc with Elasticsearch is really, really cool. And everything you've kind of done with Elastic as well. I haven't seen any questions come in yet. I might just give it a couple of seconds to see if any do come in, or if any come in kind of post the event as well. We can make sure to connect you with Milan. I am going to pop that QR code up for the swag one last time. Someone messaged me to say that they missed it somehow. So yeah, maybe I'm pointing the wrong way. Sorry. So wherever Piotr was pointing there, that's where it is. And I don't think we have any more questions coming in.
Yeah, if I may just tune in for like a little pointer, I really love. I mean, this is the second time, Milan, I've heard your story. What I love about it is the bottom line that preparing your data for search is something or somewhat different sometimes than keeping the data as you keep it in like a relational database, right? This is the experience you had with nested aggregations or avoiding the scripting, right? So just as in regular databases, we have to like think about data in a different way for when it comes to searching, and this experience and performance and cost saving, we have to like think a bit different. Yeah, so this is my point. I enjoyed hearing this the second time, really. Thank you.
Thanks a lot. You are absolutely right. We are actually consuming the data mainly from database, and it was the pain point. We had to really adjust the data structure, optimize for search, and it helped. It helped a lot with our relevancy and performance.
Yeah, it's just shifting these gears, right, in our minds that searching is something different than keeping data for the record.
Absolutely.
Perfect. Okay. I think that's everything. So thank you so much. And we hope to see you again on the next virtual meetup.
Don't
Thank you
forget
for
to
having me.
subscribe.